All right, thank you guys for joining. So my talk is going to be on Terraform Workspaces and Modules. What are they and do I need them? So a little bit about me. I was in the Marine Corps prior to working in IT. I graduated my bachelor's degree in my 30s, so I'm a little late in here. I started my career as a release engineer. And in my free time, I love to cook, barbecue, and have a glass of bourbon or two. We're gonna have a couple of quick demos or a couple of quick slides for one Terraform. Raise of hand of who used Terraform before. Okay, good amount. So for the most part, Terraform is really, its power is infrastructure as code and creating infrastructure as code and making it same thing every time. What are workspaces? So we have the description, but if you really want to think about workspace, what workspace does, it allows you to use all of your Terraform scripts and share them across different workspaces, and each of the workspaces will actually keep its own state, so they're independent of each other. And then finally is going to be our Terraform modules, again with the description. But you can think of Terraform modules similar as a microservice. You could break down all of your Terraform resources, combine them into different categories, and then use what you want to use when you want to use it based on your projects. So I'm gonna have a quick demo, somewhat quick. What we're gonna run through is a very basic Terraform script. What I'm gonna create is gonna be a local DTR, a kind cluster. We're gonna deploy a cert manager, Kubernetes dashboard, and a user, and we're also gonna tie that DTR into our cluster. When we get to our workspace demo, we're gonna talk about use cases for multiple workspaces. We're gonna show the divisions between each workspace, and we're gonna create and delete workspaces and show the states between the two. And then for our module concept, we're gonna talk about the use case for modules, the module structures, passing variables between modules, and enabling and disabling modules. So our demo is pre-recorded because anybody that uses Terraform knows that sometimes it takes forever to run that apply. So as I mentioned before, the first thing we're going to do is we're going to look at our main TF. If we look at the main TF, it's just going to create a local DTR. It's going to do it at 5001. It's going to create a kind cluster. It's going to tie that DTR to that kind cluster. And then it's going to deploy our cert manager, our dashboard, and create a user.
DTR, can you mind just clarifying?
Docker Trusted Registry. So what we're doing is we're going to go ahead and run a Terraform plan. I like using the out command. What that pretty much does, it just takes your plan and puts it into a file. That way you don't have to when you run the apply, you don't have to rerun the apply. It just runs whatever's in that plan. As we saw in our main TF, we're going to create our local DTR. We're going to create our cluster, and we're going to create our 5001 for our DTR. If you notice, everything is kind of like jumbled out of order. So by default, Terraform tries to run everything in parallel. So one of the things that we're doing, if we go back to our main TF, we're using what's called depends. What this is pretty much telling Terraform is don't run this resource until the resource in this depend is created. So we have depend with our cluster or with our user. And the other one is because we're tying our DTR, we're using depend with our cluster to only run after that DTR is created. So let's go ahead and run apply. And because we're using the out command, we just run the apply based off that file. So from here, you can see the local DTRs being created as well as our cluster. So if we go into this window, we run Docker PS, we're going to see we have our clusters creating and our local DTRs created. So we're going to look at our local, and we see that our local DTR is up and running on 5001. So let's test, make sure that is correct and everything's working fine. So we're just going to pull Nginx latest. We're going to tag this Nginx to tag it to our DTR. And then we're going to run a Docker push to push it into our DTR. So now that we have it done, when we go back to our DTR and localhost, we're going to refresh and we see our Nginx images there. So we know our DTR is good and everything's fine. It's deploying our cert manager right now. It's also creating our dashboard. And in a second, it's going to create our user. We have this nice little out command. So if you want to do the token and everything, it kind of tells you how to do it. But for right now, for demo purposes, we're just gonna make sure that it's up. So we're gonna run our port forwarding command, and then we're gonna hit the local host, and we see after we run this is unsafe because it's localhost. We're gonna see our clusters up and running. All you'd have to do is tie in our code or the token. So let's go ahead and destroy this. So we see it, regular Terraform script, and we go, okay, I got this. What's the point of workspaces? Well, everybody knows if you want to repeat this in multiple places, you could always just copy it and just init. But when you need to make a change, you have to now look for where all those changes are. And you never find them all. There's always one that's lost somewhere. So that's where workspaces help, because it's actually going to use, it's going to share those projects. So we see that the cluster is gone and the DTR is gone as well. So let's go ahead and look at our workspace directory. So we're going to open our main TF here. For the most part, everything's going to be about the same. The resources are going to look the same. The biggest difference is you're going to see now variables. Instead of hard coding, we're going to use variables in our main TF. Everything else is the same. You're going to have all your resources created. Because we're using variables, you have to declare those variables with Terraform. Instead of having everything in one file, we have a nice variable TF that we're going to declare all our variables. We have most of them with defaults, but we also have a couple empty because we do want to make sure we're using those variable files. So it's not going to run unless you use those variables files. We're going to create a demo 2 and a demo 3 cluster. Demo 2's registry demo 2, as well as ports 5002. And our demo 3 is going to be just called demo 3 on port 5003. So we're going to go ahead and run our Terraform init. The reason I'm running this from scratch is I want to show you guys, I'm not adding anything. We're not putting anything in there. By default, Terraform is already using workspaces. Whether you know it or not, you're using a workspace. If you run Terraform workspace list, you're going to see the default workspaces there. So let's go ahead and create our demo 2 workspace. We'll use a simple command, Terraform workspace new, demo 2, and it's going to create our demo 2 workspace. And in my editor, you can see here on the right, our demo 2 is showing. So we're now in demo 2 workspace. So same before, we can run the Terraform plan. The key difference here is because we're using override files, we're going to use a bar file command, and that's going to tell Terraform what override file to use when you're creating this project. And again, we're going to use that out command. So just as before, you can see all of the 6 resources being created. And then you're going to see that you have demo 2 that's going to be showing in there, as well as port 5002. All right, so let's go ahead and apply this on that file. So once this is applied, right away, we're going to see our local DTRs being created, same as before, as well as our cluster. So when we go back to this terminal, we're going to run Docker PS, and you're going to see our demo 2 cluster, as well as our demo 2 local DTR. So we go back to our local host, and we're going to change this to 5002, and we're going to see that our DTR, just as before, got created with those variables. Now we have to wait. This is why I'm trying to speed up a little bit. So it's creating our cert manager, and soon it's going to create the dashboard as well as our users. Any quick questions? I'm just kidding. You ain't got that much time. No, if you got a question, I can pause. You got a question?
You want me to hold till last, or?
Oh, no, go ahead. I can pause it. I was just joking.
What's a use case for what you're building?
So this is just kind of showing Terraform itself. These scripts I've used myself when I'm creating my local cluster. So in my previous job, I was doing a lot of CI/CD and a lot of Helm deployments, stuff like that. So I created Terraform script to create my kind cluster. I added other modules in there to tie it to what my project was doing in that company with like the different gateways and rules and stuff like that. And I was able to test out all of my Helms charts locally and then destroy everything and keep going. So I didn't have to, run through the pipelines or run this. But this is because it's just a demo. I want to kind of show it small, but towards the end, I'm gonna actually show you how we're using it within JFrog and the use case of how that looks when we tie all 3 of the things together. So play.
Did you do anything to change the workspace? I saw you did the Terraform workspace list and it had the default, but before you kicked off this other run,
Yeah, so I ran the command Terraform Workspace New, and that creates a new workspace with the name I defined. And then there's ways to switch. It's same thing, Terraform Workspace Select, and you can select between your different workspaces.
What is it? What is Workspace giving you by doing that?
So I'll show you in a second. So as we saw before, we created a resource and we created everything. So one of the things I'm gonna show you is our Terraform state list. This is the 6 resources that this workspace created using these Terraform projects. So what we're gonna do is we're gonna show you the difference between workspace and having to copy it over. So we're gonna run a new workspace for demo 3, Terraform Workspace new demo 3. And then what we're gonna do is we're gonna run the same command again, Terraform state list. But when we run this command, you're gonna see that this workspace is completely empty. So whatever happens in one workspace is not gonna be affected in the other workspace. That allows you to tie your project into multiple workspaces without sharing the state file between each of them.
But is it the same physical folder on the OS?
I didn't change the folder. This is the same folder. So you could think about it, you could think of it almost like a nested folder. So the Terraform runs, it has all of your Terraform scripts. It has your variable TF, your main TF, your modules, everything that you want to think of is there. When you create workspace, what this is saying is hold my state in this location. So when you create your first workspace and you create your first project, all of that state is going to show here. So if you switch to your second workspace, all your state's going to be here. So a quick example, and I'll show at the end too, kind of how we're using it. If you're doing dev, test, and prod, you want to keep your dev, test, and prod exactly the same. The difference is you're going to want different variables between dev, test, and prod. Workspace allows you to use the same exact code in dev, test, and prod, only change those variables so you know exactly what's going into dev, test, and prod because you're just updating the variables there. The other thing it allows you to do is if you need to make a change, and I'll show you with modules because this is the benefits for modules, is you can actually use specific versions of tags without breaking everything else because you can put in a count or you could put in a flag to say, use this module or don't use this module. But we'll get more into modules as well.
Question over here.
Yeah, go ahead.
How it applies to infrastructure as a code approach? I mean, if you save code Terraform in Git and you want to manage different environments from.
So I'll show you at the end of the demo, I'll show you kind of how we're using that, and that's gonna kind of go in there. Because again, this is really, to be quick, is just a simple kind of cluster DTR. But with Terraform, you could create everything. You could create a network layer, you could create the Kubernetes clusters, you could create databases, you could tie them in. When I get into the modules demo, I'll show you how you could even pass values from one module to another. And in that same concept, you could pass one module, you could pass values from one project to a different project. You have one too?
Second question, yeah, and I apologize, I can't see, the text is too small, so I may be repeating something that's already been explained, because this looks really useful. The workspaces, do you need to be, are they like current working directory dependent? Or can you just be in one directory and indicate a workspace and fire it off?
So it's in the same directory. Wherever you run that Terraform init, that's where all of your workspaces are gonna go. So and that's the other benefits of workspaces. You don't have to move to different directories. Everything is kept in the same directory. The main TF file is gonna be exactly the same. The only thing that the workspaces are gonna hold is the actual state itself.
So do you indicate the workspace as an argument to Terraform init?
No.
Okay.
You just run a regular Terraform init. By default, you have a default workspace.
What's the command that indicates the workspace if it's in the same directory?
So you could use Terraform Workspace and then subcommands. You have Terraform Workspace New, Terraform Workspace Select, Terraform Workspace List.
And after that, Terraform init or whatever else you want to do.
You only have to run the init once. Yeah, once that project, you run that init on that project, you don't have to do anything else. You don't have to add anything, you don't have to tie anything. You just name the workspace you want and go from there.
yeah, it sounds really useful. What about the, because I would, like the old way I did it was like you said, probably copy to the directory. What about typically your variables are different. How are you managing that if it's still?
So the way we're using here is we're using JSON file. And then we just manage the JSON file. The reason we like JSON files is because it's easy to manipulate. If you have the correct automation, you can add variables into that JSON file, or you can remove variables into the JSON file. By default, everything with Terraform just the .tf. So you have like a .tf for everything else. But we like JSON. I personally like JSONs too.
You specifically select whatever JSON file is for your work project. So you have like a dev.json.
Correct. So the best way to do it is I love naming conventions and I love having everything the same. So if you name your workspace the same as your override file, the same as your project, you can have your automation that's gonna look for your override file, is gonna look for that workspace that uses that override file, and is gonna tie that project to that workspace into that override file. So then you don't have to fumble around. So automatically pick up, so if you're testing in dev, it'll automatically pick up the dev Terraform file you use. Again, when I'll show you on some of our things, I'll show you how many clusters and how many projects we're handling with this, and it just makes things so much easier because you no longer have to CD to multiple directories and move around or anything like that.
But still, it goes back to his question about the relationship of the workspace to the source code repository.
So the relationship to the workspace is the main TF, and that's the only thing that it has. So anytime you change anything in your main TF, when you run a plan or apply to your workspace, it will pick it up. The benefit though is that what you apply to one workspace does not affect the other workspace. And this is what we'll show right here, is when we run we're gonna use our demo 3, and we run this, we're gonna create the same resources that we did before, just as we did before with demo 2. But we're gonna use our variable file, and it's gonna be called demo 3. We're also gonna deploy our DTR, and it's gonna be our port 5003. So we're gonna run the apply again to this. And then when we run the apply, we're gonna see that our demo 3 cluster and DTR is being created. We run the Docker
So you have
PS.
two DTRs running on two separate ports right now.
I'm gonna show you right now. So we have our demo 2 cluster in our demo 2, as well as our demo 3 and our demo 3 DTR. If we go here, our demo 2 DTR is still up and running. We're gonna change this to 5003, and we're gonna see our demo 3 DTR is up and running as well, parallel, using the same scripts without having to move around. All we're doing is changing the workspaces. So then, okay, we know we could have 2 workspaces simultaneously. We're gonna run our Terraform, when this ends, we're gonna run our Terraform state list, and we're gonna show that what was once empty, we're gonna now see the resources that we had that were just created with our demo 3. 3, 2, 1. And this is all the new resources that got created within this workspace. So again, independent from demo 2 workspace, they handle themselves. So let's go ahead and destroy it, because why not?
But your TF wars file was different.
No, everything was the same. I never moved my directory.
You change the port now.
No, with the variable files.
Yeah, that's why I said TF wars.
That's the override.
Well, so we're using it, yes, it's a TF file, but yes, override file, but it's independent from our main TF.
So when I was speaking about the JSON file, that's what he did.
That's our TFRs. So we're not using TFRs only because it's easier to manipulate a JSON file than it would be a TFR file. But it's the same concept, and we keep it separate from our main TF. So then you could label as many override files that you want. I call them override files, and you could create as many override files as you want, and it's not going to be cross-contaminated between each other because they're independent from the actual main TF itself. The main TF is only going to have the code and then the variable itself, but the value of those variables are going to either be in the default section with the Terraform, the variables TF, or the override file for the project. So because we're using the override file, var file, we're using the command var file to pass in the override file. Just to ensure, because we have those empty brackets, is going to show you have to pass in those values. So we can see all of our resources that were created are now going to be destroyed. So let's go ahead and destroy them. When we destroy this, what we're going to see is everything is getting destroyed. We'll go back and we'll run our Docker PS, and we're going to see the demo 3 and demo 3 DTR are gone. When we go back to our localhost, we'll see our demo 3 DTR is gone, but our demo 2 DTR is still there. So it's like, all right, we got workspaces, that makes sense, that's good. What is we're gonna run a Terraform state list. Oh, actually, pass that. So that was good, that's great. What benefits do we have? So again, this small 6 resources file, we have a file that's 142 lines creating 6 resources. So let's go ahead and look at our modules directory.
Just out of curiosity, right? The Terraform itself is in a Hashimoto, whatever format.
Yes.
But your variables are in a JSON format.
Yes. Yeah, you could actually store them in different formats. Again, JSON for us is just easier to manipulate. We have a lot of automation that will actually go in there and will change variables to either turn something on, turn something off, or upgrade certain things at certain times.
Because it's a JSON, you can use it as external tools.
Correct.
I have a semi-burning question, and feel free to delay till later if it's not the right time. So I was self-taught like maybe a lot of people, and I found that my Terraform scripts were very infrastructure dependent. Is there a way or a school of thought or a style of doing it so it's infrastructure independent? Maybe you can switch between various hybrid multi-clouds, you can redeploy from AWS to Azure.
So we're actually multi-cloud here. We're deploying to AWS, GCP, and Azure. And what we did is we broke the 3 apart. Some of the modules were shared between the three providers, but a lot of times, a lot of people, they're using specific clusters for specific cloud providers. So they're kind of put in a separate place. All our modules in the same directory. But what we're also doing is we're actually breaking that out even further. We have like a network layer, we have our cluster layer, and we have a database layer. Using how I'm gonna show you in a little bit on passing variables for modules. Not only are we creating our network layer, which is our VPC, our net, and all of that, when we create our cluster, it's going to automatically grab that VPC values. It's going to automatically grab all those security groups that got created within the first project and bring that in because of that naming convention that we're using that matches everything. And it's actually going to go into that workspace, bring in those values, and then tie our cluster into the VPC that we wanted. And we're doing that across all 3 clouds.
My question is a little different. My question is, if I've got all these resources deployed on Azure, and for lack of a better term, these objects, the namings indicated the infrastructure, and I want to redeploy to AWS, I would have had to completely write new scripts. And is there a way to make that agnostic?
It depends on it. Again, it depends on the resource you're creating. Now, if you're using GKE and EKS, no, because they're different modules. But if you're doing so there are certain ones that we are sharing across. Like if you're just doing a regular Postgres and you're not using RDS or anything like that, you can. So it really just depends if you're using a specific resource from that cloud provider, you can. But if you're using your own resource, so a short term, if you're just deploying a regular bare metal Kubernetes, or if you're deploying Rancher or any of those type that are not tied to clusters, yes, you could reuse that same module across all different cloud providers.
Thank you.
I would say like virtual machines, like if you just wanna, like I want a virtual machine module then I wanna indicate in the module whether it's gonna be in AWS, Azure. Doesn't really work.
Yeah.
Like it doesn't work very well. But what he's describing is interesting. The idea that like you would deploy that infrastructure and then on top of that, you can have a module that's generic enough that it'll work on, you know.
So it just depends how you break it apart. If you want to keep everything together, there's one way, but you could also have it separate to where it can be deployed wherever, it doesn't matter because it's going to pull in the values from where you want to go. So let's go into our modules directory. So when we open this main TF, again, what we showed before, 6 resources used to run 142 lines. Right now, the same 6 resources that we're creating is only going to use 28. The other difference is instead of calling resources, we're now calling the modules itself, and we're calling different modules. All our modules are being picked up by our source directory. For demo purposes, it's just a relative path. But what you really want to do is use Git. What this will actually do, it will check out your Git repository on either your tag or your branch that you want, and it's going to bring in that module in the project. The other thing that we're using is a flag. We're using a count variable, and what that's going to do is going to tell us if this value is set to true, then run this module one time. If it's set to false, then don't run this module. And then the other thing we're doing is we're showing how we're passing in value because we know our cluster needs our DTR information. On the line, you're going to see module.dtr.local clusters. That's actually pulling the value from the DTR module and ingesting it into our Kubernetes cluster module. And to show how that works is we're going to open our modules directory in our relative path right now.
So you switch from workspaces to modules now?
Yes, this is modules.
Is this something you wrote or is it something that Terraform provides?
No, this is something I wrote. Well, so modules is provided by Terraform. Again, you could create modules. All of this is provided by Terraform. It's a free with Terraform instance. You don't have to buy. I heard this before, and this is one of the reasons I did this demo, was you have to use Enterprise in order to use modules and workspaces. That's not true. Modules and workspaces come right out the box with Terraform. You don't need Terraform Enterprise for any of that. All you have to do is create your modules, tell Terraform where those modules live, and then go that way.
So your line number 8 is something comes with Terraform. It doesn't, you didn't write, you didn't write your own custom module.
No, comes with Terraform. So when we look at our modules directory in the relative paths, we see the same modules that we have. I have a couple little extra ones because I do have an Ubuntu one. And we're just going to look at our DTR. Our DTR looks exactly the same as it did before that we saw on our workspace. The difference is when we look at our output command, we're going to see that that local DTR value is actually going to be outputted by Terraform and is going to give it this value for that variable. This is how, when you run the cluster command, it's going to pick up that value and tie it. And again, because of dependencies, Terraform knows it cannot create that cluster until that DTR is created, so it can then ingest that value. Again, we're using override files. We're going to use demo 4, and in demo 4, we're going to create a DTR called demo 4 on port 5003.
Override files by convention. You have to specify that as that's the directory.
So in the command that we have here, I'll get that in a second. One of the things I want to show would be our init. When you run the init and you're using modules, the biggest difference you can see is you're going to have the initialize module. By default, if you have modules in there, Terraform is smart enough to go look for those modules depending where they're at. Because they're in the relative path, it's just going to look for in that relative path. If it's Git, it's actually going to check out from Git based off the branch or tag that you put in there, and it's going to bring it into your project. That also helps because when you're running different tags and different versions, you don't have to go to different places. It's all right there within the projects, and they're all being shared within that same project. So we're going to run the plan command with the var file, and I'll pause real quick. It looked bigger, but if you see that var command, that's where we define the override file that we want to use, is using that var file override, that var file command. So one of the things before we saw that we were creating 6 resources that we created on all of our other Terraform scripts. When we run this command, we're going to see most everything else is going to be created. But the thing that you can see is that this is only creating 5 resources. And if we saw that flag before, we had the count. So if we look into our override file, we see that we have it false. So let's go ahead and remove this false to see if it's going to create our 6 resources and how or why it did that. So we remove the false, we run the same plan command. And then you can see it went from 5 to 6. But the biggest difference that you're going to see is that when we go to our variables, by default, we're saying true. So if there is no override for that flag, it's going to automatically create that module for you. If you don't want that module, then you're going to go ahead and say false in your override file. So let's go ahead and say false because it'll save us a second or two on the Terraform plan. So again, we're going to run the plan one more time to that demo 4 JSON, and we're going to see it went from 6 and it's going to go back down again to 5. So let's go ahead and run this apply. So after the apply, we're going to go and we're going to see our DTR and our clusters being created one more time. When we go into our directory, we're going to see again our demo 4 DTR and clusters being created with the modules instead of using everything inside your main TF. again with DTR2. If we go back here, we saw that O3 was gone before, and when we go back to O3, we see our new DTR was created just as before. So when we talked about before, why use modules? It's only 6. What's really the use case? So for an example, this is actually what we're using in JFrog right now. We're using this is to create our network layer, and we're using our workspace. If we run a Terraform workspace list, and we're just going to do a count just to show the amount of workspaces that we had, you're going to see that in this project alone, we're running with 67 workspaces. So we're going to do the ls to our override files, and this is kind of how we have our separation between our override files. And then let's see how many resources we're creating. So if we run, if we look at our main TF, this is how our project is. I have to pull it in from a different window. And this is all what our main TF looks like. We're using modules, we're using variables, we're using the get with the tag and the reference to the tag we're using. And then we're also using counts to bring in and not use modules. So just for example, on this 220 line, we'll see how many actual resources we're creating on an only 220 line file. If we run a Terraform state list again, like we did before, this is going to show you all the resources that just this one workspace itself is being created. Let's go ahead and do a count so we can actually see a number of the resources that we're creating. And in this workspace alone, with this project on 220 lines, we are actually creating 95 resources. And then times that with the 67 workspaces that we have and all of the value and all of the overrides we have, plus on multi-tier, multi-cloud providers, as well as breaking up into projects. So each cloud provider has multiple projects. It's not just this one. Any questions?
Still question about workspace and infrastructure as a code. So
Workspaces and what?
and infrastructure as a code. So how you can manage your workspaces configuration as a code?
So workspaces really isn't the code per se. Workspace, if you think about it, is just a subdirectory. So one of the easiest ways to manage it, if you use that naming convention, then your project, your automation that you have behind it, because while this is fine locally, we don't manage all this just locally either. You can have automation that sits behind Terraform. There's a lot of tools out there that use Terraform automation that can create those workspaces for you and will tie those projects to that workspaces. If you use that naming convention, it's kind of one stuff I'm using here and I've used before. If your project matches the same as your override file, then you don't have to have different names for different projects and different workspaces or whatever. Everything is going to be the same. Another key thing to that is, as I mentioned before, because we have a network layer and we have our cluster layer and we have our VPC layer, and they're all in different, because they're broken up. When I create my VPC and I create all my groups and everything in there, it's going to create that workspace. Now, when I create my cluster, if I call my override file the same as my workspace, the same as it was in my network layer, and you put in the command as we saw before with data and the output, is going to automatically look for the override file and the workspace that you have, match that with the override with the workspace in the network layer, and it's going to automatically ingest all of those values into your cluster layer. So you don't have to look, oh, what was the security group for this again? No, that's automatically going to be ingested.
Yeah, right. But so I do a workspace 1, workspace 2, workspace 3, okay? I run everything, I'm happy. Dev, prod, stage, okay? Now at some point I'm going to say git push origin, right? The moment I say that, what's going back to git? Is it a bunch of files, one file? What is going on?
So what you want to do is, and I don't have this here because it's just workspace. So the best thing to do is to have, is to keep your states separate. So you could use S3 as a placeholder to have your state file. So, and then in your git override or in your git ignore, you put in anything that has .terraform in there because you don't want your states and you want all of that going into git. You don't. You really want that in a separate directory. When you're using automations, the same thing. If you have an S3 bucket, then it doesn't matter who runs it because those overrides and those states are going to be shared across everybody that has access to that S3 bucket and again, who has access to that project. So when you run that push to master, the only thing you're pushing to master is the main TF, the Terraform scripts itself that are being shared across all workspaces. And that's where the automation is. While you can do this all locally and share it with a lot of developers, but you'll run into some issues with states and with two people trying to work on the same thing. If you have that automation behind it, then that helps you with the states or the conflicts between multiple people. The other thing.
So the new hire coming into the group, and if there's a git clone, they're not getting the workspaces.
Yeah, as soon as you run Terraform in it, they'll get the workspace. Now, if they may not get access to the S3 bucket,
Right.
but yeah, because the workspaces come with Terraform itself as part of the initialization of Terraform, yes, they'll get all those workspaces tied in there.
Matter of fact, typically when you run like if you just download Terraform, you run Terraform and you say, I want 3 different workspaces, right? Dev, pilot, prod, or whatever. And you have the templates that Carlos showed us. When you run it and it creates the resources, it creates a state file, JSON state file locally, right? So and then you switch your workspace and you go to pilot, you run it again and it creates another JSON file locally. This is by default. But typically, like in a real production environment, what you do is you say, I'm going to create a remote state. I'm going to store the JSON state in an S3 bucket. And it's pretty easy to do that in Terraform. You just, there's just some code that you do. You indicate that you want your state in that S3 bucket. And then every time you run the state, it updates that JSON file in S3. And when you update your Terraform templates and you push to Git, then typically you're going to run a pipeline, right? And your CIC like GitLab or GitHub or whatever is going to have access to the state files in S3. So that's where your state file lives. And when you clone the repo, you're cloning the configuration that is your state file for your different workspaces. And when you run it, you're pointing again, whether you're running it in the pipeline or you're running it locally, you're pointing to the S3 bucket state file. Does that make sense?
How you share code between teams, how you work, different teams work on the same models?
Yeah, so because we're using that same concept of storing everything with the S3 bucket, anybody that initializes this will be able to access those S3 buckets. Because we're using modules with Git tags and Git references, you're able to pick a staging cluster and run on that cluster, and it's not going to affect anybody else because that module on your branch is only running for you and you're only updating your state for that cluster. Everybody else is using the state file that's in Git itself and master without that branch tag, and they won't see any of the changes that you have until you commit it. When you do commit, again, if you're using that Git tag or the branch, I prefer tags, honestly. When you're using that Git tag, then those modules will only pick up based off of that. The count and the flags is the best thing to use, because if you're creating a new module and you're adding something that you're still testing in test, then you could put the default as false. So once you merge that in, everybody else use that project will not pick up your change until it's ready. Then you just go in when you're ready for prod, change that flag to true for that project, and then now it's going to pick up that change.
Have you heard about Terraform?
Terraform?
Yeah.
So what's Terraform?
It's it allows you to manage your multiple environments.
It's a wrapper on top of it.
Yeah, this
It's
is
like a
concept.
hero type of thing.
Don't repeat yourself, so you
sort of,
don't use the same code in different places.
So I would suggest when you start getting into big projects, using something like that, because it helps with breaks and states. Because somebody could test something and forget that they checked it in. And then you can have those projects like N0, Terraform Enterprise, and then they're going to monitor your states and all of that as well. But that's nothing free. You obviously have to pay for that. So this is kind of just showing a free tier of how they're created and how you can use them. And then you could go out and pick either your DAT or Terraform Enterprise or N0 or whatever else tool to sit on top of that to manage your states.
Yeah, Terraform Workspaces are pretty awesome. We use them for deploying different environments, like you mentioned that use case. And then I also work in crypto on different blockchain networks. So we use them for like developers deploying their own sort of like local network to test against. You mentioned before that you guys have use cases that you're using. the environment one is pretty is pretty common. Do you mind explaining other use cases or just giving more ideas or examples of use cases that workspaces really come in handy besides environment?
So I mean, so to me, this goes for anything. It doesn't even have to matter with environments or with cloud providers. Anytime you want to share your code to multiple places, that's what workspaces are for. Because you don't have to copy. If you find yourself copying the same codes to different places, you might as well use workspaces. It goes for the same concept with modules. If you're constantly having to copy stuff over because there's a module, because there's a change in one of your resource and it's affecting somebody else's, that's what modules are for. You could break out your modules to different places, and it's easier to read 220 lines than it would have been if I had this all without modules. It'd probably be 1,000-line TF, and nobody wants to read a 1,000-line file.
Thanks, Carl.
And we'll
Two
do
questions,
one more.
but I'll ask them separately to be respectful of the other folks. The first one though is, we talked about the free tier versus enterprise. I didn't know enterprise existed. What is enterprise? What does it do? And what's the profile of person or company that you?
So I don't use enterprise either, but from my understanding, enterprise just gives you the automation on top of Terraform, and it also allows you to manage your state files. So there's a lot of companies out there that does that too, like N0 and stuff like that. And that's all it's doing, is just taking it and putting that extra layer on top.
Well, if it's so simple, I'll steal my second question too then. And that is, I've only run into it once, but what is the relationship between TerraGrunt and Terraform? Same company, different company? What else does it do versus what Terraform does?
So I don't use
They're a
Terraform.
consulting company.
Was that
So
completely
I
different?
think one of the main principles there wrote one of the big Terraform books, Terraform Up and Running, where it's a popular Terraform. So I think that's what it is, yeah, but they're actually not part of Action.
Got it. Okay.
Question.
Which one that we got? All
I
right.
think we're gonna have to
So you could talk to me after.
definitely check with Carlos. How can people get a hold of you,
So
Carlos?
I'll be here. I have a LinkedIn. I think it is Carlos Traitel.
Carlos T?
Yeah, Carlos T.
Carlos T at JFrog.com.
Yeah, Carlos T at JFrog.com too. But I'll be here after this. So if you guys have any questions, feel free to talk to me.
Put that to the world, please.
Hey, thank you so much, Carlos. That was